for the lecture today. So this morning we cover almost 90% of chapter 1. We just go and reflect and do a little bit on material selection. What we cover this morning is we look at 4 types of material: metals, ceramic, polymer, and composite in a brief way. And we look at few charts. For example, density, metals will be the highest among the other groups. The rest we read out. So this one will help you to elaborate, especially for the first part of the question. For this module, your question will have A, B, C section. A will be more on the theory side. B will be on the calculation. C will be on the explanation on the value that you calculate, right? Or answering the question how or why. So this part will be more on the section A kind of question, right? So second one is on the stiffness or elastic or modulus Young. This one, you will see this one more in the material properties in chapter 3 or chapter 2. Okay. It's important. Right? So metal and ceramic were almost the same. But polymer will have a very lower stiffness elastic compared to metals and ceramic. Composite is a combination of this one and this one. Because composite, you can combine these 3 materials. You combine these 3, you get strength. This is a tensile strength. Later, we'll go into material properties. We will look at this tensile strength. Metal is the highest, and polymer is the least. Rest of it, Then the ones is resistant to fracture. Metal is the highest. Polymer, they are very weak, especially when you cool it. They are very easily to break away. Ceramic also. Composite, you will take the strength of metal and strength of ceramic combined to get a wide range of the. Then this one is the electrical conductivity. So electro connectivity, later you zoom into the microstructure, you look at the electron in the orbit. Okay, so if they're able to transfer electron out, then conductivity is there. If no stable, then no conductivity. Okay. Now, next we look at this one is. Now we look at processing and selecting material. So the rest you read. So for selecting material, normally the question will ask you, what is the, after you do all the analysis, you select maybe 10 material, you narrow down maybe up to 4. So from the 4, you further do analysis that which material do I now select for the particular application. Okay, so the question, when you do material selection question, normally it will give you like 20 or 15 material, a list from table with the properties. Then you do analysis. It will give you a statement. Then you do analysis for the maybe part B. So after you do part B from the 15 or 20 list, you narrow down maybe to 5. So after narrow down to 5, they in the section C will further narrow down, will give you another specific application. So from this 5, you narrow down maybe to 2 or 1. So for this module, there's no 1 answer or 2 answer. Normally the answer will be more than 2 or maybe 3. Then you need to explain why this 3 or why this 2. Okay. So for example, I'll give you an example. A carbonate beverage container, for example, Coca-Cola and Sprite in the glass. Why you need to contain them in the glass? So you need have all these constraints, right? So for example, you know that all these drinks, they are under pressure. So the container or the material need to handle the pressure. And they need to be non-reactive or chemically stable with the drinks chemical inside. They need to be stable. Then they need to relatively strong in logistic dimension. Okay. And they need in the costing side. You need to consider the last one, the last part, you will look at the costing. Right. So for this module, section C, normally you need to analyze on the costing. They give you like $5 per kilo or $3 per kilo within the few material. These three material, then you do the analysis, then you give the best answer, best selection among the material. Okay, so this one is inexpensive, and it can, because it's a drinks, you need to look attractive to the consumer. So for this kind of beverage container, you will choose optical transparent. So in the early morning, you have alumina something that have three types of transparency, right, in the morning. So you can look back in the morning slides. And also, you have a flexibility in your production, so you can produce in a different color. The plastic can be green color, red color, and so on. Okay, so these are the constraints for application. So even maybe you work in the F&N or in the pharmaceutical, later on you are producing the capsule for the medicine. So all this you need to be also under material selection. Okay, right. So for this application, there are three types: metal, ceramic, and polymer. Okay, so it can be glass, it can be thin glass like this. Okay, so then you need to answer what is pro and cons. Pro and con is based on the graph, the few graph that I show you just now. Based on that, explain, right? Then the process of design will be this diagram will help you to do further explanation, especially section C kind of question. You draw this diagram, consists of design, processing, and material. Then you start discussing on the design. You look at the statement in the question. They will say that the service condition or the environment that in the question you just mentioned, what is the function and what is the cost involved. Then you go into processing. So processing, you look at equipment that you use, the influence of properties, and the cost, right? Then you go into the material properties also. So one is you look at the process and then look at the material. So there are two, both also involve cost. One is the processing cost, one is the raw material cost. So there are these two. Design, this one is more on the maintenance and all this. So this slide will tell you when the question asks you to elaborate on the relationship among material processing and engineering design. So if the question asks you this keyword, explain the relationship among material, the processing of the material and engine design, the question actually asks you to draw this one and explain a little bit about this diagram. So this kind of question will cost you like 7 to 8 marks. So the diagram, this one 2 mark, 2 mark, 2 mark, 6 mark, and then explanation maybe another 2 marks. So it's very easy to score. As long as you see any diagram, any features that you can draw, usually will come up in the question. Because that is the way to we assess your understandings. Okay. Again, for this module, we don't test your grammar, but use simple English, or if things that you cannot explain, you can use diagram to explain. And label carefully, and especially the labeling in the diagram, in our module, if you use a certain formula or a certain alphabet, for example, pressure equal to force divided by area. So if you use this one, P, to represent pressure, then you use P. This one represent force, this one represent area. If you use the normal alphabet, that we cover in the lecture, then it's okay. But if you use outside the lecture, let's say you want to use Q to represent pressure, in your answer, please explain what is Q. Please write Q equal pressure in your answer if it's not a conventional alphabet that we use in our lecture. Okay. Okay, so this one you see, this morning also we see these four items: processing, then we go to structure, then we go to properties and look at performance. So this table will tell you like study a certain chapter. All right. So for example, processing is on the process. We will learn about diffusion. Again, we have 4 learning outcomes for this module. So those absent this morning, please go back to the previous recorded video, go and listen. We have 4 learning outcomes. This 4 learning outcome is important because that is the way we ask you question. Okay, LO1 learning outcome number 1 will become in your test 1, question 1, and also final exam question 1. LO2 will be question 2 in test 1 and final exam question number 2. LO3 will be in your test 2 question number 1 and final exam question number 3. Then LO number 4 will be in your test 2 question number 2, final exam question 4 and 5. Okay, so you're just referring to the keyword there. So we'll look at diffusion, the crystallization, and so on. So structure we'll look in depth in next chapter or next week. We look at crystal structure and so on. There's a calculation for that. Properties, this one we learn in your lab and also in the mechanical property chapter. Okay, then and so on. So all these are labeled which chapter we'll go to. So this chart will be useful when you come to your final exam revision. Okay, so now maybe is still very fresh for you guys, but this slide is important for your final exam revision. At least you know like what happened throughout the semester. Okay. So this also the same table. So these are the chapter that we will be covering lah. Okay. So try to score in test 1 and test 2 because that will be the question will be a bit simpler compared to final exam question. Okay, and is very specific to a certain chapter only. So try to score high marks in test 1 and test 2. Okay, so this is summary of all the chapter. Same. Okay, so these are all the question that will test your knowledge and understanding. And you can go and check whether you understand or not. For example, yeah, you can go and check now. Huh? So these are all the question, a sample question that you can ask yourself whether you know how to answer or not. Okay, some of it will be we'll re-engineer the question and ask in your test 1 or in your final exam. Okay. Yeah. So there are lots of questions, and the first one is on the knowledge and comprehend problem. This one may be on the section A kind of question. It will look something like that, but it will not be the same lah. It's just in that kind of principle, huh? Okay. Then the second one is the analysis and application. This one is section B or section C of the question. So if for example, it asks you, what class of material does a PTFE belongs, and so on. This one, you see this word when you come to polymer. Okay, come to polymer. Synthesis and evaluation. This one is more on the more similar to final exam question already. This one a bit more complex. For example, this one, name the important criteria for selecting material used in the protective sport helmet. So what are the criteria? What are the criteria? Criteria means you look back at the few graph that I show you. the stiffness, and also all this, all right? And then identify material that would satisfy this criteria. And then what would be a solid metal helmet not be a good choice? So you need to answer why metal helmet is not good for as a protective sport helmet. You need to explain why. For example, sport, because you are deal with impact, right? Impact. So metal, they easy to deform when it come to big force. So you talk about stiffness, you talk about the tensile strength and all this. Okay, this one just a few sample for you guys, right? So with this, we conclude chapter 1 already. Chapter 1 we finish already. Just flashback how this module was designed. Just recap, and then we call it a day. Okay. So this is the fourth LO, the learning outcome that is important. That is always you refer to when you come to your test, your lab, or your final exam. Okay. So as you can see, the first week is more on the understanding or recap or refreshment on your uh, chemistry class, right? So next class we'll start look at the periodic table that you learn in your chemistry class. So we look at crystal structure of atom. We look at very, very small microscopic kind of cases. We look at atomic. Then we look at crystal structure. Means we look from atom. Then we grow a little bit bigger. We look at structure, a crystal structure. Then we grow a little bit bigger. We look at defect in a solid. Defect means holes or crack, how this deform. Then we look at the process, diffusion process. Okay, diffusion process. Then a bit bigger, we look at mechanical behavior in week 6. Then strengthening mechanism, ductile, brittle fracture. Then metal alloys phase diagram in week 10. Okay. Then polymer, ceramic, composite, and the last week will be electric and electronic materials. So electric and electronics material I do not cover in the previous January semester, but your semester we will go into electric and electronic material. Okay. So this will be the roughly the ideas. Okay. So let me end the recording.